Young. I'm served as the advisor to the set of extraordinary grad students who actually conceived, designed, and organized this workshop. They did so with a lot of help from Carol Holm, as all the Zyger groups do. I'd also like to mention that for the last year, Marissa Vasquez's lab has kindly given up a whole room to these students once a week to meet. I want to thank her as well. Just as a little bit of background for the overall UC Davis end of this, this workshop is part of an NSF training program called IGRT, which is an Integrated Graduate Research and Training grant that is designed to expose students in a wide variety of fields to each other and to the other fields that are outside their own. And this is they come in these packets. This is a 4 or 5 year grant. This is the last cohort of that grant. The PIs on that are Sharon Strauss, Rick Grossbard, Holly Doremus, Kevin Rice, and Jim Riesemer. Okay, and as I said, each cohort tries to ask a question that spans beyond just if they're ecology, or if they're just economy or social science, and integrate them in a very innovative way. And that's what you're seeing today is this cohort's version of that thing. The previous cohorts in this group studied the Williamson Act, the effects of the Williamson Act on ranchers. Some of you may know about that. Fragrance products as an emerging environmental issue, and multivariate analysis of floodplain restoration are some of the other cohorts that come through. But today, today's workshop is about juniper encroachment, and many of the experts of juniper encroachment are here today, and they know a lot about it, and many of you also do. You're going to hear a nice introduction to that, I hope, today, and an overview. I just want to let you know that this is a massive problem, and it covers hundreds of thousands of acres of the western United States, and it's a real issue for all sorts of environmental impacts that you're going to hear about today, and one that has still not been resolved, even though they've been working on it for half a century or more. It's still a major issue, and hopefully you'll hear more today about some of the innovative things that are being attempted. So today what we're going to do is we're going to start with several speakers, again, experts in this area from outside, and then the IGRT students will present a statistical, spatially explicit model of juniper encroachment that they've developed over the last year. Then we'll have a lunch break, and then there'll be a panel discussion and a wrap-up by Ken Tate. But before we get started, I want to introduce the IGRT cohort. They're Derek Young in ecology, Allison Diedrich in ecology, Eric Porse in civil and environmental engineering, Matt Hamilton in ecology, Gabe Sampson in resource economics, and Shayla Farzan in ecology. And Shayla will be your moderator for most of the rest of the day. So again, thanks for coming, and sit back and enjoy.
All right, thanks, Truman, for that introduction. So David Lile is going to be our first speaker today. David is the director of the University of California Cooperative Extension in Lassen County. And although he specializes in natural resource and rangeland management, he also has experience with issues that are near and dear to just about every Californian's heart, riparian habitats and watershed protection. So today he'll be speaking about western juniper in Lassen County.
Thank you. Okay.
Sorry.
Okay. Okay, just a couple things. And I apologize for my voice. I think it's been a really good year for rabbit brush. And so my allergies are at an all-time high. I thought I would be better coming down here, but whatever betterness has not kicked in yet. So anyway, bear with me on that.
Oh yeah, David, Central Valley's great for.
Yeah, I know, exactly, exactly. Yeah, right. I'm sure there's 10 other things that are twice as bad. Just a couple things before I kind of get into what I was going to present. But if anybody has interest, I have some of these Western Juniper pocket guide, kind of a decision-making matrix things. They are kind of interesting, nice pictures. Also, a video restoring sagebrush in the Great Basin, restoring sagebrush largely with juniper control. And then I think, defining technical document in terms of Western Juniper, if you don't have it, is this Biology, Ecology, and Management of Western Juniper publication from Oregon State. And I have this with me. You can take those others, you can't take this. You could look at it, right? You want that. So anyway, but some of the stuff that I'll present and some of the pictures are taken from this, but again, just an excellent reference publication if folks want to get more info on Western junipers. Okay, so what I would like to do with this is just kind of introduce the topic, make sure that as we go into today that we're all kind of have the same, not perspective necessarily, but at least a baseline of understanding that sort of thing. So it's going to be more of the fundamentals about juniper. It's not going to be the cutting edge science necessarily. But, and so for those who are already juniper experts, you probably will just find this largely review. But more and more, this is just the landscape in eastern Lassen County, Modoc County, up into Oregon. But, and we've almost come to accept these junipers out on this landscape to, this level of density and higher, but it wasn't always the case by a long shot. Just a distribution map. So the green up in northeastern California, extending into eastern Oregon. The green is the western juniper. The red dots extending down through the Sierra Nevada is the Utah juniper. And so we are talking about a species in California that is pretty, narrowly defined and ranged to the northeastern counties. So juniper, western juniper is a native species. It's not an introduced exotic sort of a thing. And that's not the norm. When we think of invasive species, we think about an expanding species. The dark green is, based on soil type, what we would think of ecologically as naturally occurring juniper, more or less fire-safe types of sites that wouldn't naturally have a lot of fuel to carry fire, and where juniper could become established and dominant on that site. The yellowish green is our current extent of juniper in the northeastern counties. Susanville, Alturas, the straight line up there is the Oregon state line. Do we have a pointer by any chance? Okay. So the crux of the juniper issue, it is this expansion, okay? Again, it's a native species, it belongs there. Again, kind of an iconic species for us, but it's this expansion out into the sagebrush type. A number of studies, and most of the studies documenting this expansion are based on tree ring data. They bore in, count tree rings, age the trees, and be able to tell, when a lot of these trees germinated and began to grow. And so expansion dates back to the 1870s and 90s. That's when we first see, that's the oldest of all these trees that are out on the sagebrush type. They tend to be in this age bracket. It really peaks from the 1900s to the 1930s, but it's still going on now. We're still seeing new juniper encroachment, new young seedlings coming in, and so it still continues. And of course, these dates coincide with settlement of the area, particularly when we had a lot of heavy livestock use in the early part of the 1900s, and kind of hand in hand with that, fire suppression. both active fire suppression and, as a consequence of a lot of grazing use, less fine fuels out on the landscape to carry a fire, and so a reduction, bottom line reduction in fire. Now there have been studies where they've documented on sites where they think we're pretty much grazing proof, where we have also seen juniper expansion. So maybe not necessarily an absolute requirement, but certainly I think it's part of what has enabled and kind of kick-started a lot of these junipers to spread out from the ecological sites where we think maybe they belong. So juniper expansion, or invasion, it's something that's slow over time. It's not like an annual weed, or even some of the perennial weeds that we think about, where just within a couple years' time you look at a field or you look at an area, it's like, wow, look at that. All of a sudden you see it. Juniper it's been a very long, slow progression. So there's pictures like this where you're from 1906 to 2007, over 101 years. You look here along underneath this rim, and you see a few scattered trees, but largely open. And now you've got almost a closed canopy. And this is pretty typical wherever we've got these older photographs of our rangelands in northeastern California to see this kind of expansion. But it's something that does slowly over time. And so if you don't have kind of this long perspective, a lot of times I think we look at it and we don't really notice that it's going on. It really doesn't ring a lot of bells for folks. Okay, just quickly, a few words about the life cycle. The seeds or the berries spread predominantly by birds. There's about a dozen species of birds that do use the berries. Townsend solitaire, robins, or bluebirds, probably the three predominant ones. The seeds tend to germinate well underneath sagebrush, as opposed to the inner spaces. And in our range sites, if you're used to the annual type, we've got a lot of bare ground, a lot of inner space. And you might think, well, that's probably where these things are getting started. Not really. You see a lot more little seedling juniper underneath sagebrush, and we think that it's microsite conditions, maybe a little bit cooler during the summer, maybe a little bit more humidity, and maybe a little bit more soil moisture collected under there. And that's where we tend to see the little seedlings get started. And they grow really slow. They go really slow until they get to sort of above that line of sagebrush, above that height, and then they really take off and grow much faster. Okay, so seedling stage, I know this is not a good picture, but just a couple of the take-home things. This sort of light blue-gray color is very characteristic, and the needles on these little seedlings are quite different looking than the needles on the more mature trees. And I know that I said, well, it's under sagebrush and these are out in the open. This is right after a chipping operation that came and opened up the entire site, and so it really exposed these small trees. And it's interesting, you look at a site and you think, okay, it's, there's not a lot of little trees out there. And you come in and you see some sort of mechanical thinning take place, and all of a sudden these small trees are everywhere. We did some work several years ago on controlling some of these little trees after these mechanical chipping operations, and we were really surprised when you really start looking. A lot of times there'd be over 100 of these little guys per acre, and you would have thought maybe there's just 2 or 3. But again, it's because they're predominantly kind of hidden underneath that brush line. And so you really start to notice them kind of in this 10 to 25 year age bracket. This is a low sage site. The sage is shorter as opposed to a mountain big sage type site. But this age tree starting to crest that sagebrush, and this is where they really start to kick on the growth. Then you get kind of these, pointed shaped trees up from, say, this 25-year range up to 150. And then juniper, very long-lived species, 1,000+ years. And the older growth juniper starts to get this rounded look to it. Okay, it's no longer kind of pointed. It's more rounded. The bark changes. And what I would point out about this picture, you see all the rocks. Now, I know that one's a rocks too, so it's probably going to live for a long time. But if you see all these rocks, again, that's the kind of place where we would expect to see old growth juniper. Naturally, you get a fire across this landscape, all the rocky ground, there's not a lot of fuel there, certainly not enough to kill this tree, and so it would survive for a long, long time on that landscape. interesting thing about juniper is it's got both a taproot and lateral roots. With young juniper, when there's seedling up through that, maybe 2-3 foot size, puts down a big taproot. That's the first thing it does. Then as that tree begins to grow, then it starts expanding those lateral roots. So on a deep soil site, it's very well adapted to be very competitive. It can get the deep water and it can get the shallow water. Now, on a lot of our range sites, you've got a restrictive layer here, or maybe not very shallow soil. In that instance, the taproot basically just stops, and it puts all its growth into these lateral roots that can be up to and beyond the height of the tree. In fact, some instances even maybe 3 times the height of the tree. But a very competitive and well-adapted species for moisture competition. All right. I don't know, I mean, at least locally, the big thing that people like to talk about with juniper, you can't even bring it up. Oh, people talk about how much water juniper uses. And so absolutely they do. This is 20, I mean, I even see sometimes 30 gallons. But when there's a lot of soil moisture available, individual trees can really crank through that moisture. And again, very competitive for it with the other plants on the site. Another thing about juniper is, not just the water that it uses, but the water that it can intercept. And different studies have come up with slightly different numbers. The highest one, I think this was an Oregon State study, estimated up to 70% of a closed canopy of precipitation was intercepted by the tree. And on smaller size storms that we get less than a 1/4 inch of water, basically that canopy, that vegetated canopy, is catching the whole thing. A lot of these juniper sites, 8, 9, 10, 12 inches of precip per year. If you're capturing 70% of that, there's not a whole lot left over. And we already talked about the root structure, but again, they can get up to 6 inches of soil moisture in a growing season. Junipers, you gotta respect juniper. And we talked a lot of negative tones about juniper. I mean, certainly it's a species that we wouldn't want to lose on our landscape completely by any means. And so a lot of people have the juniper growing out of the rock picture. And if you think it's just a optical illusion, there it is, the trunk right out of the middle of the rock. It's truly growing from the rock. Anyway, gotta respect a species like that. So more landscape ecology kind of focus here. Rick Miller up at Oregon State kind of has defined 3 phases of juniper expansion. And so this would be what he would call phase 1. It's still relatively open, young trees coming into a site. I think I've got, So phase 1, you still got kind of an intact understory. You see a lot of sagebrush here. You see some herbaceous understory. There's not much berry production on a site like this. These trees are immature. They're putting most of the resources into growth. And they're young trees. They just don't produce much berries. You still have new trees coming into a site like this. There's still a lot of space in here for new trees to come in. These trees that are here tend to be growing fast. Now, it all depends on the range site and how deep the soil is and that sort of thing. But relative to juniper, this kind of site, you're really seeing fast growth over time. The other thing I might point out is from a restoration perspective, you still have quite a few options at this point that maybe are not super cost prohibitive. And if you did come in here and control these trees, you really wouldn't have to do much in terms of your understory. It's already there, okay? You wouldn't have to reseed. You wouldn't have to wait a long time to get this understory back. So phase 2, a little bit denser. You see these junipers coming into a stand of mountain mahogany. In phase 2, you're still actively growing. The individual trees are still growing fast, but this shrub layer is starting to disappear, okay? And it could be anywhere from, still pretty good shape to really a lot less shrubs on the ground. Berry production in these kinds of stands tends to be pretty high. So if for whatever reason you're managing or you want to manage sites for birds and that sort of thing, these sites are the kind that do produce the most berries. And even that is quite variable year to year, but compared to the other stands, berry production would be high. And then you get to phase 3, which is the almost closed canopy type site. And unfortunately, we've got far too much of that. Now these trees have really slowed down their growth. You know, they're almost side by side. The individual trees are not growing that fast anymore. Shrub layer is almost gone at this point underneath the trees. And there's not as much berry production, again, because of the intercompetition between the trees themselves. Maybe just backing up real quick. When you, again, we think about restoration of a site in phase 3 versus a site in phase 1. You know, you couldn't use prescribed fire very well on this site because the fuel load is so high. If you were going to try to do something, you know, if you did treat this site, you'd almost certainly have to do some seeding. And the time factor in terms of from when you treated this to when you have kind of a desirable sage step sort of an ecological site, you're talking a big number of years, maybe 20, 30, 40 years before you get that back to what, you know, is ultimately desired. Okay, so wildlife effects. You know, we have a variety of sagebrush dependent or obligate wildlife. Mule deer aren't on that list, but I really consider them to be, they're at least a sagebrush facultative type species. But, you know, sage grouse petitioned for listing. Pygmy rabbit's been talked about for listing. I'm not sure about all the others. Soil, you know, long-term impacts to soil. The sediment yield on a closed site of juniper without a lot of understory is a lot more than where you've got a good understory cover in place. And as you might expect, the susceptible places are these interspaces between the trees. It's two-year versus 50-year runoff interval. What that means is on a site where you've still got good understory, it takes about a 50-year event to get obvious surface runoff on that kind of site. Where we've lost that understory, you'll get obvious runoff even in like a 2-year storm event. And so much more frequently. From water yield standpoint, we think, well, that might be good. But if we lose this surface soil, we're talking long-term degradation of that site and the potential resources from that site. So, a lot of negative things about juniper expansion. Hey, it does have value, absolutely. I mentioned about birds. Thermal cover for deer. You know, especially, now this deer is in the shade in the summer, obviously, but bad weather, cold weather, big juniper trees, definitely thermal insulation for deer and other kinds of wildlife. Firewood, it's great firewood. It's my choice of firewood. Not as fun to cut. And nice to have a teenage son to split stuff like that. But it is good firewood. Paneling makes beautiful paneling. It is a little bit hard to mill. There's only a small number of people that even begin to try to work with juniper, but it does have values. One of the things, especially when we talk about things like paneling and firewood, fence posts makes great fence posts. Those kind of values tend to come from the big trees, not from the little spindly 80-year-old trees. And so that's another kind of, you know, conflict, is it's kind of those big trees that we don't necessarily want to remove that much from the landscape. But a lot of the value that we gain from juniper are more from those bigger trees. And I guess the thing to think about maybe for the rest of the day is this balance between the values that juniper provides and its, you know, inherent place on the landscape and the impacts that this expansion has had on other resource use in the area. So that's where I'm going to stop, and we'll talk a little bit more about grazing stuff in a little bit while, but if there's any questions, I'd be glad to try to answer. Otherwise, we can move forward. Kevin?
Yeah, so David, this sort of reminds me of like that whole issue of mesquite in the Southwest, right? So how much of a portion of this is filling in versus actually going to new places? You know, to actually really engage new areas? Because that one picture you showed in 1906, it sort of filled in. They were there already.
Right.
In.
I mean, there's different stages, and so, you know, I do think that there's an expansion into new sites.
Okay.
And once that expansion starts, then it fills in from there. So it's almost like a two-stage process the way I see it. We see sort of these scattered juniper start to pop up on the landscape out in the sagebrush steppe sort of ecological sites where we really don't expect it. And then over time, those start to fill in the gaps. And I think it gets back to the fire regime question. I think ultimately this is the final successional stage, naturally, of these sites. And fire keeps setting that successional stage back. In the absence of fire, that's what's going to happen. So I think it's functionable, but I do definitely see, and don't have any pictures, but I know sites, in my mind where you just sort of see it's like an advancing front. Some of the folks will talk about, like a little army of juniper pushing forward.
Maybe just a point of clarification, and only because I speak to it from having helped more people lose more money on utilization than maybe anybody in this room, is that in actuality, the 80 to 100-year-old tree gives us more yield if you're going to be sawing, and the reason is the bigger trees have higher taper, bigger knots, more bark, and more rot. So
More yield for
if you're going to make paneling or some
paneling.
kind of
Okay,
sawing
great.
product. So that's just a minor point of clarification,
Yeah.
that we've done the yield studies, we've done the recovery studies, and by all means, the folks who are trying to make a commercial use out of it would far prefer the 80 to 100-year-old than the larger. And you can see a great example there.
Yeah.
Even if you have a teenage son, that's great rod, but it's not good for sawing.
Yeah. Thank you for that clarification.
When these phase 3 stands do burn, does it kill the stand, or is the fire much more intense than it has been? What does it look like after it burns?
It does sort of depend on the intensity of the burn. Certainly natural fires will kill juniper. You can get kind of this moderate level of fire that doesn't if the tree's not all the way consumed. But in general, even under kind of moderate conditions where we do prescribed fire, the juniper that's consumed will die. The downside in that is if we want to manage for sagebrush, any fire that is going to be effective at taking out the juniper is also going to take out the sagebrush. And so it's a number of years before you start to get that brush community back in.
Is there a relationship between the spread of cheatgrass and juniper encroachment?
Relationship between cheatgrass?
Yeah.
I don't know that directly there is. It is an issue where people want to come in and do some sort of juniper treatment, because any kind of on-the-ground treatment like that is going to have ground disturbance. And so if you're in a cheatgrass area, prone area, you certainly could expand the cheatgrass component. For us, I really look at sort of elevation as one of the controlling factors. If we're above, say, 5,500 feet, we usually don't have a big cheatgrass issue. If we're down 4,500 feet, it could definitely be. And so that's kind of an evaluation where, do we treat this site, or do we have a seeding component to this site, because the cheatgrass could come in.
So, not only do these trees use water and intercept water, but because we create a runoff, and all three of those things, does that mean there's less groundwater? Is that kind of one of the thoughts, or is there any evidence?
I don't know, and maybe somebody else does, of specific studies that show that, but I would say, yes, that would be one of the expected results. Anecdotally, there's a lot of talk about spring flow, and spring flow being enhanced from juniper treatments. The people up at Oregon State have done some paired watershed stuff that kind of indicates that spring flow can be enhanced where juniper's been treated. I think yes. I don't know how well and how clearly it's been documented, but I would strongly suspect that's the case. Okay, thank you very much.